Problem on your worksheet, if I can find mine. There it is. So this says, factor each and fill in all the zeros. One factor has been given. So I need to find all of the roots of this polynomial. You could graph it and find the roots that way, but we're using factoring only. But there's a problem. We don't know how to factor x to the thirds. Some of them factor in a special way, but most of them don't. So what we're going to do is use the one given factor and divide it. So we're going to take, we have an x to the third that looks like this, and it has 3 roots. And I already know one of the roots. What is it? -5. So x equals -5 is one of them. So let's say it's that one. Well, if I divide, I'm going to end up with a quadratic, and that quadratic will hit right where those other 2 roots are. So we do x and 5. The root is -5. The factor is x plus 5. So x to the third, x squared, 5x squared. So I have 5x squared. How many do I need? I need 4 more to get to 9. So this would be 4x squared. 4x squared divided by x is 4x. 4x times 5 is 20x. I have 20x and I need 23x. So I need 3 more x's. 3x. This is plus 3. 3 times 5 is 15. Now, I already knew that my remainder was 0, right? Well, they told me one factor has been given. So I knew it was a factor, which is why I could trust it as a root. Because if the remainder is not 0, then that number is not a factor, which means that the negative of that is not a root. So now I have x squared plus 4x plus 3. How do I find the other 2 roots? Factor. So x squared and 3. Are there factors of 3 that add to be 4? So 1x and 3x. So x, 1, and 3. Hold on, listen up. Shh. So when I'm factoring quadratics, I put in the first box and the last box. Then I times those together. And then I find the factors of that number that add to be the middle term, which happened in this case to be 1x and 3x. Okay. Yeah, you can factor it the old way if you want, but if your quotient has a leading coefficient, you have to use the box. So I put in x squared, and I put in 3. Now, x squared, you follow? So what are my other 2 roots? So -1 and -3. Well, there's 3 on this one because it's an x to the third. Okay, how many is number 3 going to have? So, Colette, look at number 4. Or number 3, sorry. Shh. Everybody look at number 3. How many roots are there? 4. I already know 2 of them. One of them is 3, and the other one is 0. How do I know it has a 0 root? There's no constant, right? I can factor out an x. In number 3. So if it doesn't have a constant, then the y-intercept is 0. But if the y-intercept is 0, then one of the x-intercepts is also 0. So really all you're doing is x to the third plus 3x squared minus 13x minus 15 divided by x minus 3. Or, if you're really brave, you could have done the original and divided it by x squared minus 3x, and you would get the same thing. Okay? So that takes us all the way through the first page. Look at the second page in this last part. So number 13 says, factor each and find all of the zeros. 1 0 has been given. So one of our answers is 2. How am I going to figure out the others? So I need to turn it into a factor. So x minus 2, and I'm going to let you guys do that. But 14 is a little harder. So this one is going to be x plus 1/5. Well, I know x plus 1/5 equals 0, but I don't like this. I can times it by 5, because 5x plus 1 equals 0 is exactly the same thing as x plus 1/5 equals 0. Right? The other way to do it, which might make more sense to you, so x equals negative 1/5. How do I move the 5 back over? Multiply. How do I move the negative 1 back over? You add it, and now it's a 0. So anytime you have a factor with a fraction, move it to the other side and then multiply it by the denominator. You can still do division with fractions, but you don't want to. That's a royal pain.
So that one we'd like do the box with 5x.
We would do the box with 5x and 1. Yeah. Okay. Get to work. Do you still want to go? You can go.